Simplify3D. Simplify3D is the program that I use to convert the STL files to G-code for my 3D printers. I use the same settings for all the parts, with one exception, the tube holders. That part required me to add some small amount of support material on the bottom section of the part. In a previous video I talked about the design considerations I had to make for these parts. What I did not tell you in that video is that I also designed the parts so they would be easy to print without support materials. The main settings that I used for these parts are a layer height of 0.2 mm, a bed temperature of 50 degrees Celsius, an extruded temperature of 225 degrees Celsius for the first 3 layers and 215 degrees for the rest of the print, an infill of 25% in a rectilinear pattern. I used 4 bottom layers, 4 top layers and 3 outside shells for additional strength and enough material for the mounting holes. In most cases I printed only one part at a time. This gave me additional flexibility in when I printed the parts, and if I had a malfunction, only one part would be lost instead of a lot. Besides that, it doesn't really add that much time to the total time required to make the parts. The printing took quite a while, in total around 37 hours. That is because I needed to make quite a lot of parts, and that was also because the print speed was set quite low. The reason for the low print speed is that I'm printing on a Wahao i3 printer. These printers are quite nice, but they lack rigidity, and when you increase the speed of the print, the quality will get worse quite quickly. I am using black PLA filament that I bought from WebWeb World, and it's offered under the name Real Filament. It's not expensive and I'm getting good results with it. So these are the finished parts. I got 3 motor mounts, 3 pulley blocks and 3 guide rail car assemblies. In total there are 21 parts, excluding the mounting hardware, electronics and the pulleys. Now first we are going to assemble the guide rail car blocks, the motor mounts and the pulley blocks. And when that's done, the next step will be to assemble the linear motion modules. The first step in making the guide rail car blocks is mounting the offset blocks to the main bodies. This is done with 4 M3 screws on either side. The next step is to screw on the tube holder with 2 M3 screws. The limit switch trigger is mounted into place with 2 M3 screws. Finally, I added the 4 M4 screws for the next step of the assembly. The next assembly is the motor mount. I placed the NEMA 17 motor on the mount and fixed it in place with 4 M3 screws. After that, I placed the limit switch on the sidewall and fixed it into place with again 2 M3 screws. The final subassembly is the lower pulley block. The only thing I needed to do for this part is with a long M3 screw put the ball bearing pulley in its place. With all subassemblies finished, it is now time to assemble the linear motion modules. These 3 towers make up most of the 3D printer's frame. The first step here is mounting the pulley block on the bottom of the frame. I am using 2 M6 bolts with T-nuts in the slots for this. Next I am fixing the guide rail block to the car. This is simply done with 4 M4 screws. When that is done, it is time to install the motor mount. I put it in place but did not yet fix it because I needed it loose to be able to tension the belt later on. Next I took the belt and put it into place. Off camera I cut all the belts to the same length. I fixed the belt into place with 2 M3 screws on the guide rail car block. Before I close the frame, I insert 3 M8 bolts in these slots that I will use for the final assembly of the 3D printer. After that, I close the frame with a second long part of 4040 aluminum extrusion that is bolted into place with 4 M8 bolts.